Hello friends, today there is another very simple question, that is simplify cubic root of 8 plus 3 root 21 plus cubic root of 8 minus 3 root 21. This is a simple question and it is based on the polynomials chapter. So let's see how the solution is done. So this is the question. First I will consider this 8 plus 3 root 21. This is equal to a, and since this 8 plus 3 root 21 is itself a real number, therefore the cubic root of this thing will also be a real number. Now I consider 8 minus 3 root 21 to be equal to b, and since this number is real number, therefore its cubic root will also be a real number. Since cubic root of a and cubic root of b both are real numbers, therefore the cubic root of a plus cubic root of b will also be a real number. And we have to find a solution of this question which is a real solution or a real number solution. So for this, what I do is I assume cubic root of a plus cubic root of b to be equal to x. Now this value x, a, b, all this I will implement in this question, and this question is written in this form, that is cubic root of a plus cubic root of b is equal to x. Now I will cube both the sides of the equal to, that is here also I will give cube and here also whole cube, so it becomes x cube plus cubic root of a plus cubic root of b whole cube. Now this can be expanded using this formula of a plus b whole cube. The formula is a plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square. So upon expanding it on this formula, we will get x cube is equal to a plus b plus 3 cubic root of a whole square, and then multiplied with cubic root of b plus 3 times of cubic root of b whole square multiplied with cubic root of a. Now here what I will do is this square terms, all these terms that are having squares should be brought under the cubic root, inside the cube root. So what I will do is that cubic root of a whole square can be written as cubic root of a square. Similarly, cubic root of b whole square can be written as cubic root of b square. Means I brought the square terms inside the cube root. Now again this a square and this b both are under cube root, so I can bring this a square and b terms together under one cube root. So this becomes cube root of a square b and this becomes cube root of b square a. Finally we got this a square can be written as a into a and b square can be written as b into b. So finally I got x cube is equal to a plus b plus 3 times of cubic root of aab plus 3 times of cubic root of bba. This is what I got in the previous slide. Now this AB and BA both are identical. We have to find the value of AB and BA. Since we have the value of A and have the value of B, so we can find the value of AB. So AB equal to BA equal to 8 plus 3 root 21 times 8 minus 3 root 21. So this can be written in this form, that is 8 square minus 3 root 21 whole square. So how is this form coming? This form is coming from this formula, that is a square minus b square is equal to a plus b times a minus b. So this can be further simplified in this form and the answer will come as minus 5 whole cube. So the answer of AB equal to BA is minus 5 whole cube. The value of AB equal to BA is minus 5 whole cube. This is that. Now that equation x cube is equal to a plus b plus 3 times of cube root of aab plus 3 times of cube root of bba. In this equation we can replace the value of ab or ba with this minus 5 whole cube in this equation. So this becomes like this, that is instead of ab we are writing minus 5 whole cube and instead of ba also we are writing minus 5 whole cube. So again on simplifying, what will happen, this minus 5 whole cube inside a cube root can be brought outside. In this also the same case, so minus 5 is brought outside and inside the root it is only a, inside the cube root it is only a, and inside the cube root it is only b. Further this 3 into minus 5 becomes minus 15, here also minus 15. This minus 15 can be brought common and inside the bracket we can keep these two terms like this, that is minus 15 is common and cube root of a plus cube root of b. Now we recall from the previous slides that x is equal to cube root of a plus cube root of b was assumed earlier. So that value can be implied in this equation that we got in the previous slide. So if we put here, that is this cube root of a plus cube root of b, this value is x, so we will put the value of x over here. So we get x cube is equal to a plus b minus 15x. Now the question is, what is the value of a plus b? So a plus b value can be calculated from this part. So a plus b is equal to 8 plus 3 root 21 plus 8 minus 3 root 21. This plus and minus terms will get cancelled and a plus b will equal to be 16. This we will put over here. So x cube is equal to 16 minus 15x. This is the final derivation that we got from this equation. So we are looking for the value of x such that the x is a real number that satisfies this equation, and that will be the solution of our question. So x cube is equal to 16 minus 15x we got. So we are looking for the value of x such that x is a real number. This can be written in an equation form, that is x cube minus 16 plus 15x is equal to 0. Now we have to find the root of this equation. So for finding the root of this equation, we will use the standard values of x, like x is equal to 1, 2, 3 or minus 1, minus 2, minus 3, and put in this equation and see in which value of x is this equation getting satisfied. So upon doing that, we are seeing when x is equal to 1 and we putting this value 1 in this equation, we get 1 cube minus 16 plus 15 is equal to 0. That means this x equal to 1 is satisfying this equation, and hence x equal to 1 is a root of this equation. So we can say that x minus 1 is a factor of this equation. So if x minus 1 is a factor of this equation, we can factor out x minus 1 and the remaining terms will be x square plus 6x plus 16 equal to 0. So we got one real root, that is x equal to 1. And also in some graphing calculators like the Desmos and other free softwares, if we plot this equation, we are seeing that yes, this equation is cutting the x-axis at x equal to 1. Hence x equal to 1 is its only real root that exists for this equation. Now the given that we derived, that is x minus 1 and the remaining terms x square plus x plus 16 is equal to 0. This x minus 1 means that x equal to 1 is a real root of this equation. This we got one of the real root. This is why we got one of the real roots. But what about this part? X square plus x plus 16 equal this part. So for this part, for finding the root, we use the discriminant method, in which we calculate the d discriminant. The formula of d is discriminant is b square minus 4ac, where a is the coefficient of x square, b is the coefficient of x, and c is the coefficient of 6. C is the constant, not the coefficient, sorry. C is the constant 16. Putting the values of a, b and c in this discriminant formula, we get d is equal to 1 minus 16, that is equal to minus 15, which is less than 0. Hence the roots are imaginary for this part, and we know that imaginary roots exist in pair, that is conjugate roots. Therefore this cubic equation, this equation is of order 3, so it is a cubic equation. So this cubic equation always will means an equation which is cubic in nature will always have 3 roots. Now from that 3 roots, one root is real, that is x equal to 1 is a real root that we have found out, and the other 2 roots are imaginary. We are interested in the real solution, so we will consider this x equal to 1 only. So we got the answer as of this as 1, because x equal to 1 is its only real solution. Real means the real number solution. So it is quite amazing to see that a complicated simplification questions of arithmetic can be solved using polynomials and equations, and we got the very simple answer, that is 1, for this complicated question. So this is a very amazing type of question. In some softwares like Wolfram and Alpha, if we plot this simplification questions in the computer, they give a very complicated answer, a complex root with non-zero imaginary part, and they give only one root, whereas this answer should have 3 roots. So where is the problem? Actually, the softwares like Wolfram and Alpha is showing only the principal root of this given simplification by using the principal range cut algorithm. To see all the 3 roots in softwares like this, we use the cube root function. So the cube root function, when applied with this question, will give the result as 1. So it is proved. I hope this is a very simple question, and I tried to show some simple use of computers also while solving such certain questions. So I hope this question is clear. Thank you.